chi-square goodness of fit test in SPSS using method 3. Chi-square test is a test that can be used when there is one categorical nominal data or variable. Nominal data that have at least two levels in it or two categories in it is called dichotomous variable, such as life or dead, male or female. The nominal variable can have more than two levels in it, such as professions: doctor, dentist, scientist, and pharmacist. The test also, the chi-square test, can be used to analyze data that are ordinal. The test will examine whether there is a difference between observed frequencies or count compared to expected frequencies or count. So the test will examine the hypothesis that there is equal proportion or unequal proportion. Here in this data view, I have a nominal variable that have 200 cases in it. By clicking at the variable view, the nominal variable have 4 levels in it. The first one is doctor, the second one is secretary, the third one is pharmacist, and the fourth one is nurse. To perform the chi-square goodness of fit test, first of all, it examines the proportion or the count for each level within this variable by two methods. The first one is drawing a bar chart. The second one is looking at the frequencies. So if we click at graphs, chart builder, click on OK, select bar chart, drag it to the empty space, drag profession to the x-axis, click on OK. A bar chart is generated, and there are 4 categories or levels in this: nominal variables, and nurse have the highest count and doctors have the lowest frequencies. We could also look at the number of cases or frequencies for each level, and to do that, first of all, we need to split the data. So click on data, click on split file, click on compare groups, select and drag professions into the empty box, click on OK. Now click on analyze, click on descriptive frequencies, untick display frequency, click on statistics, click on sum to count the number of cases for each level, click on continue, drag the profession to the variables, click on OK. A table is generated showing the frequencies for each level within this categorical variable: doctors 34 and nurses 70. To perform the chi-square, I will show you how to do it in a different method. I'm going to calculate the frequencies for each level or categories. I will generate a new window in SPSS and generate 2 new variables. Call the first one jobs, the second one frequency, and change the measures for the jobs as it will be nominal, and for the frequencies it will be scale. Align them center and decrease the decimal to 0. And for the jobs, we'll insert the 4 categories: 1 for doctor, click add, 2 4 secretary, click on add. 3 4 pharmacist, add, and 4th for nurses, and click on add, click on OK, click on data view, adjust the width here a little bit, increase the width, and for job insert 1 2 3 4. So we have doctor, secretary, pharmacist, and nurses or nurse. Going back again to the data here, we had found out that there are 34 cases in the doctors category, and 54 for secretary, 42 for pharmacist, and 74 nurses. Insert the frequencies for each categories: 34, 54, 42, and 70. To perform the chi-square goodness of fit test, first of all, we need to weight the cases for this variable, which is the frequency. Click on data, click on weight cases, select frequencies, select weight cases by the frequency. So the software will weight this variable and will perform the chi-square. To do the test, click on analyze, scroll down to non-parametric test, then to legacy dialogues, and then click on chi-square, and in the chi-square window select jobs into the test variable list. Click on exact, no changes. In options, select descriptive, click on continue. Here we have two other options: whether we are going to analyze the data based on a hypothesis that all the expected frequencies are equal or not, and here the other one is whether to include all the levels within a variable or exclude one or more levels of the variable. If we click on OK, 3 tables are generated. The first one shows that there are 200 cases. The second one shows the observed and the expected values of frequencies for each level. The frequencies for the doctor is 34, and then for the expected frequency it is all set at 50, equal proportion for all the 4 categories or 4 levels. For the residual, which is equal to observed value minus expected value. Looking at the third stat table, it shows that the chi-square value is 14.7, and the degree of freedom, which is 4 minus 1 equal to 3, and the p-value is less than 0.05. So here the test shows that there is a significant difference between the observed frequencies compared to the expected frequencies. We could also go back again to the test and set the value here. Let's say that we need the set the hypothesis to be of unequal proportion, and since we have 4 levels from 1 to 4, I'm going to set the first value of let's say first proportion for the first level to put it as either in proportion or in count. For the first level, set that for 0.1, add for the second one 0.2, add for the third one 0.3, add for the fourth one is 0.4. So here we are stating that the expected value for the first level will be 10%, second will be 20, third will be 30, and fourth will be 40%. and that in number will be 0.1% of 200 will be equal to 20, and 0.2 is equal to 40. The third one is 60, and the fourth one is 80. Click on OK. Again, a test will recalculate the value for the chi-square, and as shown here for table 1 there is still 200 cases. For table 2 the expected value is set at 20, 40, 60 and 80. And looking at the chi-square, the value is 21.3 and the degree of freedom is 3 and the p-value is less than 0.05. Go again to the chi-square test. Let's set this at default, all categories are equal, and then let's say that we want to analyze only 3 levels within these 4 levels, from 1 to 3, excluding the nurses from this analysis as shown here in the table. The first one shows 200 cases, the second one shows only doctor, secretary, pharmacist, and the nurses are excluded, and here we have 130 observed compared to expected, and the expected value or frequency is of equal proportion, and a chi-square value is generated for 0.6 and a p-value is 0.096. so this test shows that there is no significant differences between observed and expected frequencies or values. So this is the way to perform chi-square goodness of fit test in SPSS using a third method.